There are two key components of PBN. The first is Area Navigation, or RNAV, and the second is Required Navigation Performance, or RNP. Prior to PBN, aircraft had to zigzag from one ground navigation station to another. Air traffic controllers needed to block large areas of airspace around the aircraft to compensate for the variations in flight. With RNAV, aircraft fly more direct and optimized paths, and air traffic controllers can block smaller amounts of airspace. We get even more precise with RNP. The aircraft is contained within a narrow corridor, and the procedures can be designed with pinpoint, predictable curve paths that provide even greater operational opportunities. With PBN procedures and repeatable curve paths, we can improve flight efficiencies in all phases of flight. Let's explore how this next-gen initiative is helping to address the challenges of our congested skies and environmental concerns, from departure through the en route to arrival and finally to the landing or approach phase. The departure phase. Atlanta's Hartsfield-Jackson International Airport, where 10,000 RNAV flights now depart every week. Because aircraft no longer are restricted to fly over the ground systems and navigation precision is greatly increased, we can create more departure exits or on-ramps to fly into the en route airspace. This expedites aircraft away from our airports into the overhead streams efficiently. For the airspace users, the traveling public, and the surrounding airport communities, this translates into departure efficiencies, which helps to reduce fuel, time, and emissions. Aircraft depart with minimal controller voice instructions, greatly reducing the complexity and communications between the pilots and controllers. So now we have the ability to create more on-ramps. So how do we improve the use of our runways to allow the planes up in the air faster? Options are limited for adding more departure paths and runways. The FAA is addressing this challenge by implementing new spacing standards based on the use of PBN. For aircraft departing an airport today, controllers launch successive aircraft on different courses or headings. This is limiting and uses large portions of airspace. The FAA's new standard, in use today at Atlanta, is called Equivalent Lateral Spacing Operations, or ELSO, and here's how it works. Using PBN, procedures can be designed that use less airspace, providing for additional departure paths from the runway ends that were otherwise not possible. The added paths increase runway efficiency without putting the planes any closer together. At Atlanta, this enables the controllers to handle the same traffic demand on 2 runways versus 3. NextGen is now seeking to expand this capability to other airports by developing a national standard. Now let's look at the en route phase, where aircraft are transitioning to and from our airports. Because we are free from the ground-based systems, we can plan and fly more direct and wind-optimized paths and better address restricted use airspace. In some areas, we need to expand the limited en route road system into a highway system by adding routes where needed and otherwise not possible. PBN enables us to fly optimized direct routes or multi-lane highways to serve multiple airports and connect high-volume metroplexes. In the arrival phase, as flights near their destinations, we need to efficiently exit them from the en route or highway system. As more exits or on-ramps are enabled for the departures, likewise more exits or off-ramps are enabled for increased arrival efficiency. PBN arrival procedures can be designed to allow the aircraft to descend efficiently by reducing or eliminating the need for level flight. This design is called an Optimized Profile Descent, or OPD. OPDs improve how the aircraft flies from the higher altitudes down to the runway, reducing engine noise, saving gallons of fuel per aircraft, and reducing carbon emissions. In the approach phase, our flight is coming in for a landing. With more precise navigation, more accurate and curved path approaches can be placed where needed in limited airspace, improving access and providing greater options to avoid challenging terrain or noise-sensitive areas when possible. The FAA and industry are working collaboratively on advanced RNP concepts that take advantage of the curve path and narrow containment to eliminate mileage costs, impacts, and improve access. RNP also helps to deconflict adjacent airport traffic interactions that cause flight disruptions. In many metropolitan areas, arrival and departure paths at nearby airports can interfere with each other. This means that aircraft at one airport may be stopped on the ground or held in the air while aircraft at a nearby airport are landing or departing. At Chicago O'Hare and Midway airports, flight paths share the same airspace, which results in costly delays, cancellations, and passenger disruptions. A curved path RNP approach to Midway is designed to untangle the interaction of the two airports, enabling uninterrupted operations.